Okay, let's start. Yeah, I already start recording. Okay. So over here, yeah, see you. Okay, the diagram shows a tangent APQ, okay, with the center C and center E. So there's actually two circles here, the big circle here and as well as the small circle here. So they are showing that this one is the center for the smaller circle. This is the center of the bigger circle. So every time I tell my students, every time when properties of circle, the first thing is you have to identify your radius. So over here, I know that my QE is my radius, DE is my radius. So I like to mark out that all these, I will say, okay, these are equal because they are all radius. And then at the same time, come to here, we also know CD and PC and BC, they are also radius. But of course, they are different size. So we can put marking just one. So we will know that, oh, okay, these are equal, these are equal. Okay, and when they say that tangent, this is tangent, the very popular property is the radius perpendicular to the tangent. Hello, Dylan. I also long time never see you on Friday as well. Okay, so we will put here 90 degree and put here 90 degree because radius is perpendicular to the tangent. Okay. A math tutor gathering here. Okay, so over here BF 16 cm, which is from here to here, this whole thing is 16 cm. And DF from here to here, this is 12 cm. So we know that DF actually is the diameter of the big circle. Yeah, but I'm going to watch movie after the TikTok live. Okay, so over here, we know that this is 12 cm. So I'm going to put here 6 cm and 6 cm and 6 cm. I like to label my diagram first before I start analyzing. So see, BF is from here to here, which is 16. So 16, if I minus 12, we will know that the diameter of the smaller circle is 4. So 4 divided by 2, so we will know this is 2 cm as well as 2 cm and 2 cm. Okay, put this all information into the diagram. Okay, so now they ask you to show that the triangle APC and the triangle AQE, they are similar. Okay, thank you. Okay, so when you want to prove similar triangle, 90% of the time is we're going to use the AA property. That means you need to prove that they have corresponding two angles equal, and that means they are similar. Okay, the balance 10% is using the corresponding length to prove that they are similar. So in this case, look at these two triangles. Okay, I already have this at 90 degree, so we already know that they are equal. I fulfilled one. Another one is the angle A. Angle A is common angle between the two triangles. So two angles is already equal. It means that they are similar. Okay, same angle but different shape. Then it fulfills the part where it's similar. Because same angle, if it's the corresponding length is equal, then it will be congruent triangle. So in this case, I will say A part 1. Okay, I will say that triangle APC is equals to angle AQE. And it's equals to 90 degree, and we will have to give the reason. This is because radius is perpendicular to tangent. Okay, and just now I mentioned about this angle, right? So always follow the alphabet order. So if I want to talk about this, I will say angle PAC. So I say angle PAC. So the other side, angle PAC, see PAC. So the other side you must write QAE. So it's equals to angle QAE. And the reason over here, this is common angle. Common angle. So AA already. So you will say, oh, so therefore triangle APC is similar to triangle AQE. And say that this is AA property. So we are done with the first part. Okay. Now part 2. They say hence find the length of AB. AB is this small here. So actually, a lot of times is when they ask you to prove a similar triangle, we're going to make use of the similar triangle to find those unknown length. So in this case, I'm going to form the fraction from the similar triangle. So it means that, look at this one, so it will be AP AP over AQ. So you will write part 2 AP over AQ is equals to PC over QE, which is equals to AC over AE. So let's see what whether we have the enough. We put in the information. AP we don't know. Okay, AQ we also don't know. Just leave it first. So we have our PC. PC is 2, and QE is 6. So that means this is 2. This is 6. My AC over here, I don't know what is my AB. It's okay. I'm supposed to find my AB, right? So I'm going to let AB be X. So that means we will let this be X. So my AB is X. So AC become X plus 2. X plus 2. My AE is from here to here. From here to here. So here is 6. Here is 4. And so this one is 10. So it's 10 plus X. So you will know that this is X plus 10. So this is unknown. So we just leave it. And you can see that actually this is 2 out of 6. You want to reduce it to 1/3 also can. If you don't want to reduce, it's also fine. So now it become a equation whereby both sides are already single fraction. So all I need to do is just cross multiply. Cross multiply. So it becomes 2 multiplied by x plus 10 is equals to 6 multiplied by x plus 2. Rainbow. So we will have 2x plus 20 equals to 6x plus 12. So we have 2x minus 6x equals to 12 minus 20. Minus 4x equals to minus 8. So my x is equals to 2. Therefore, we know that our AB is equals to 2 cm. So once you've done, okay, I know my AB, so put it back into the diagram and you can put here, this is 2 cm. So we are done with this, done with this. Okay. Next, they ask you to prove that angle EAQ, okay, so that means they want this angle over here. They want you to prove that this is pi over 6. Okay, when you see right angle triangle, you know you can link it to Tuakaso. So I'm going to write over here B. Okay, when you look at this right angle triangle, okay, I will have to see whether we have enough information in order to, whether we have enough information to do our theta, which we have. So if I'm going to draw out the triangle, see here, if I'm going to draw out in a shape this way, label this is P, this is C, and this is A. So I'm supposed to find this angle over here. I have 2 cm here. The hypotenuse we have 2 plus 2, so this is 4. So with this, actually we can form Tuakaso to find our angle. So based on this angle that I'm supposed to find, this is my opposite, and this is my hypotenuse. Opposite and hypotenuse means you're going to use sine. So you will say, okay, sine theta is equals to 2 over 4. So to find theta is just sine inverse 2 over 4. And you will get, in terms of degree, you will get 30 degree. 30 degree, Sine inverse half, if you keep calculator in degree mode, it will give you 30 degree. But they want it in terms of pi. So we must know that pi radian is the same as 180 degree. So if it's 30 degree, over here 30 degree, it is the same as saying it is pi over 6. Okay, and shown. So we are done with B as well. Okay, it's just using Tuakaso, using Tuakaso. Okay, now let's take a look at part C. So part C asks to find the parameter of the shaded region. So looking at the shaded region, I need PQ, I need this arc, I also need this arc. Agree? So if you want to find the arc, you can use the arc length, which is the r theta. R theta. We have our arc, no problem. But we need to find the angle. So I need to find this angle over here. I also need to find this angle over here. Okay, and also need to find this PQ. So how am I going to find the PQ? Okay, I'm going to do the working here, a bit squeezy. So over here, I'm going to find out what is my AP. Why do I need my AP? Because I can take this length minus this length, then I will know what is my PQ. So let's take a look at finding AP. I have the right angle triangle here. I can use Pythagoras theorem to find my AP. So over here, I will say, okay, AP is equals to 4 square minus 2 square. So it will be 4 square minus 2 square, square root, you get 3.4641. This is AP. Now I want to find my AQ. This is a bigger right angle triangle whereby the hypotenuse over here is 2, 4, and 6. Alright? So the whole thing is 12. Okay, 12. And I also have the 6. So that means I will say, okay, AQ will be equals to 12 square minus 6 square, and you square root it, you get 10.3923. So I have my AQ, I have my AP. By using Pythagoras theorem, I minus them, I can find my PQ. Okay, I can find my PQ. So you will say, okay, my PQ will be 10.3923 minus 3.4641. And we will get 6.9282. And this is not my final answer, so do not round off. Later part, after we find these two up, we will just add them together, then we round off. Okay, so now come back to here, I'm going to continue. So this one is continuation of part C. So like I said, I want the angle over here, right? So how am I going to find this angle? So remember just now we already found that this one, this was pi over 6. Okay, so now this is a right angle triangle. I will know that this angle over here, so I'm going to write here, I will say angle PCA. PCA will be equals to 90 degree minus this one. So it will be pi over 2 minus pi over 6. Times 3, so it's 3 pi over 6 minus pi over 6, so it's 2 pi over 6, which is pi over 3. So this angle over here is pi over 3. Now I want this angle over here. So angle PCD, PCD will be straight line, right? So it's pi minus pi over 3. Times 3, so it's 3 pi over 3 minus pi over 3, that gives us 2 pi over 3. So now I have the angle over here, this one. Now I can find the arc PD. So I say, okay, arc PD simply is using the formula r theta. And this r is 2, so it's just simply 2 multiplied by 2 pi over 3. Okay, we can leave it in terms of pi, is okay. Later then we just press the calculator. So it's 4 pi over 3. So you see, now I have already settled the arc PD. Agree? I have settled the arc PD. So I also settled PQ. All good. Okay, if you all don't understand any step, you can always ask me in the chat, and I will explain. But don't tell me, or don't tell me a question mark, or don't tell me, I don't understand. You have to state which is the part you don't understand. Like, or maybe you say, oh, Chia, can you explain again, how do you get PCD or something like that? Then I will explain about that part. Then I know what you don't understand. Okay, don't, question mark, now that I also don't know what you want to ask. So, if no question, I will proceed to find this arc here. So, this part, I need to find this angle over here. And you see, this and this, it is actually parallel. Okay? This and this is actually parallel. Just now we found that this red color here, it was pi over 3, right? PCA is pi over 3. So it means that I also know that this side is also pi over 3. So I don't have to do extra work already. I already have the theta for this bigger sector. So now I just need to find arc DQ. Okay, arc DQ. So same thing, r theta. This time around the r is 6. So it's just 6 times pi over 3. So it is 2 pi. So now I have all the 3 length that I need. I already have my PQ. I already have the arc DQ. I already have the arc PQ, PD. Add them together and that will be your answer. So we will say, okay, parameter of shaded will be equals to 2 pi plus 4 pi over 3 plus this one, 6.9282. 6.9282. So in the end, I press calculator, 17.400, round off, I get 17.4 cm. So of course, this is 3SF. Sorry, the space a little bit limited, so you have to, Okay, so for those who like, okay, you can understand 40-50% is good enough, okay, and then after that you can always rewatch the video from the from my YouTube channel. YouTube channel, you just go to my bio, click on my second link, that will be linked to my YouTube channel. Okay, all my past TikTok live are uploaded to my YouTube channel. You can always revisit that together with the PDF worksheet where you can get from the Telegram channel, but not now. You can only get it from next day. Oh wow, is this Sec 4 level? Properties of circle is learned in Sec 3 for Express. Okay, so this will be for question number 1. Okay, so let's move on. Not here. Let's move on to the next question. Hello, Raphael. Okay, now let's take a look at question number 2. So, question number 2. Look at the diagrams. Wow. I did a diploma in brain dead after NS. Mechanical engineering. I also did engineering, but not mechanical. Mine is electrical electronics engineering in NTU. I did a degree. Okay, yeah, triple E also want to kill me already. Okay, so over here, okay, when we have the main thing is very important is the first thing is you have to identify whether do you have any center of the circle. Okay, sometimes it doesn't have. You don't assume that it looks like a diameter, then you say it's a diameter. So the question will mention, so the line BE is the diameter. So good. So for me, I always make it a habit, the center, if there is a center. Hi Che, you look different today. Yes. Okay, because later I'm going to enjoy movie today. Yeah, so I'm already in my go out dress code. So I always make it a habit, so I know this is my center. I will put a dot there to remind myself, okay, that's a center. Because whenever we have center as well as a diameter in a circle, you can easily find out the angle in a semicircle, which will be the 90 degree. Okay? So in this case, let's go and find our 90 degree. So over here, this is a diameter. This point touches the circumference, so I will know this is 90 degree. And this is diameter. This also touches the circumference, so I will also know this is 90 degree. Okay. Okay, now next, let's continue. They say when produced, the line AC and ED meets at F. So produce, it simply means that the line is extended. So they are saying that these two lines are extended and they meet at F, that's all. And in other words, they are trying to tell you this line is a straight line, this line is a straight line, that's all. Okay? Then after that, this one 68 is already stated. So for by giving reason, so see by giving reason, okay, you need to find angle CDE. So where is CDE? CDE. So your task is to find out what is this angle over here. So this will use the very popular property, which is the quadrilateral in a circle. So you see 1, 2, 3, and 4. This is a quadrilateral whereby all 4 touch the circumference. So take note, the quadrilateral must have 4 points touching the circumference. Then you are considered the silk quad, or sometimes they use opposite segment. So in this case, we will know that this 68 degree plus this angle over here actually give you 180 degree. So part A, I'm going to write here. So we will say angle CDE, CBE. Oh, actually don't need let me see. Oh, okay. So straight away I can find my angle CDE, CDE. which is equals to 180 degree minus 68 degree, that gives us 112 degree. Update the diagram. Always update the diagram after you find the angles. If not, it's difficult for you to analyze the next step. So you have to give the reason, because you have to tell them why do you do 180 minus 68? Why? So a lot of students don't understand where to put the reason. The reason is beside the statement whereby you suddenly say 180 minus 68. Why? You have to tell them why, right? It's because of a property, and that's why we write that. So you put it at the side beside 180 minus 68. So you will say, oh, so this is actually angles, opposite angles in silic quad. Forever cannot pronounce this word lah, but you all know can already lah. I don't know, is it silic? My student always say, it's not silic, it's not silic. But I cannot pronounce. Never mind. As long as you know can already lah. As long as you know . So here is 112 degree. So this one resolved. Next, they want angle CEB. CEB. So they want to find this angle over here. We already settled this 90 degree, but of course later we have to state . So now, how do you find this angle over here? See here, angles in the same segment. See this one? This angle CBE is equals to angle CAE. So how do you know this angle is in the same segment? CBE, the base is CE. CAE, the base is also CE. And the A and B both touch the circumference. This is called angles in the same segment. So if this is 68, okay, that means this is also 68 degree. Understand? So you will state part B. You will say that angle CBE is equals to angle CAE, which is equals to 68 degree, and you will say this is angles in same segment. This is school past year paper 2019 ACS. Okay, it's not 10 year series. So other than that, remember just now we marked the 90 degree. So you also have to tell them why you put 90 degree. So you will say angle BCE is equals to 90, and the reason is angle in semicircle. So now I know this is 68, I know this is 90 degree, this is inside a triangle. Okay, you can find this angle over here. I have moderator around. If you all talk nonsense here or be rude, you will be blocked. Don't say I never warn you. Okay, so over here, this angle that they asked me to find, angle CEB will be 180 degree minus 90 minus 68. So we will have 22 degree, and this is angles in a triangle, and we are done. So we know that this small angle over here is 22 degree. You graduated already, but since you know that there are TikTok live, oh, say block. Block. New block. Huh? Why? No need what? Okay, my moderator oversensitive. Okay. Okay, anyway, let's come back to here. So we need to find angle reflect COE. COE, this angle over here. So you're supposed to find this angle over here. So look at this. This one COE as well as CBE, they have the same base, which is CE. The only difference is this one is at the center and this one is at the circumference. So in this case, we know that this is double the angle over here. Double the angle over here. So we will say part C, we will say angle COE is 2 times the angle CBE, which is equals to 2 times 68 degree, which will give us 136. And the reason over here, you will say angle at center equals to 2 angles at circumference. Okay, so we are done with this one, 136. So update the diagram. This is 136 degree. 136 degree, But, wait, I missed out one thing, They asked for, there's no tips. First of all, you definitely need to know all the properties. Okay, and just now, like I mentioned, the first thing is you have to always mark out where is the center. If there is a center, mark out the radius and put that they're equal sides. Okay, and then after that, next thing is, of course, every time you make sure that you read the question and all the information are put into the diagram. And every part that you settle, you must update your diagram with the answer. So take note, they ask for reflex. So this is not done yet. So I have to say reflex angle COE is 360 degree minus 136. Okay, so 360 minus 136 will give you 224. 224 degree, and that should be the answer. So reflex is referring to this one. But this one, I don't want to update my diagram because this is not necessary. This part is not necessary. So I will move on and see. Next, they ask you to prove that this is secondary school math, Sec 3. I come on live on every Wednesday 8 to 9 p.m. and every Sunday 5 to 6. Okay? So now they ask me to prove AEF. Let's see where's my AEF. AEF. So this is the big triangle and the small triangle is DCF. So they ask you to prove that they are similar. So please take note, it is not drawn to scale. If you see actually this CD and this one doesn't look like parallel. Yeah, but this is not drawn to scale. Not drawn to scale. So I have no more space. I'm going to squeeze it over here. So let's do our part D over here. When do you usually post math questions? I mean now I try to post videos on my TikTok every day, 3 questions a day. Okay, if you follow my account, you will notice that I very often I update the TikTok videos. Yeah, but no guarantee lah, no guarantee. For now is you can see that I will actually post every 3 p.m., every 7 p.m., every 11 p.m. Okay, let's come back to here. So like remember just now previous question I said when you want to prove similar triangle, you have to prove a lot of times it's about the angles, 2 angles. So let's take a look at these 2 triangles. First, again, my angle F actually is common angle. Okay, and then where else do we have that is equal? Okay, so let me see. FDC, okay, over here, I can find this angle over here by using angles on a straight line. So I will say angle FDC is equals to 180 minus 112, which give us 68 degree. So this is angles on straight line. This one is here, 68. And you see, this triangle over here, we also have a 68 degree, correct? So you see, it has 2 angles the same, and it has a common angle. So I will say, okay, angle FDC is equals to angle FAE, which is equals to 68 degree. So I already proved that the one corresponding angle is the same. And lastly, of course, the common angle. So we will say angle DFC is equals to angle AFE, which is common angle. So we already proved 2 angles is the same. So we will say, okay, so therefore, triangle AEF similar to, this is Sec 3 properties of circle, triangle DCF. And we are done. So that is for part D. That is for part D. Next, they ask part E. Given that DF blah 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 blah, like I mentioned, Every time they ask you to prove similar triangle, okay, 90% of the time is you're going to make use of the similar triangle to find the unknown length. So with this, I'm going to write out my 3 fractions. So first 2 letters, so it will be AE over DC equals to EF over CF. Do you teach primary school angles question? I only focus teaching secondary school for now, not teaching primary school. Okay, equals to AF over DF. Okay, let's continue. I'm going to write here. So let's see what information we have. Okay, AE is from here to here. We do not have, and let's see whether they give us or not. They did not give us. Did they? Yes. So you see, they give me DF is 8. DF is here. So from here to here, this is 8. CF is 6. So here is 6. ED is 16. ED is 16. So from here to here, this is 16. They ask you to find AC. AC is this one. So now over here, let's see what we have. AE, I don't have. I just leave it. DC, I also don't have. I leave it. EF, I have. EF is 8 plus 16. 8 plus 16. So this one I don't have. I just leave it. So I base on EF, I will have 8 plus 16, which is 24. My CF, I have, which is 6. AF, I don't have. But see, they asked me to find AC, right? But my AF, I can write it as AC plus 6. Okay, this is tricky. I do not have so-called AF. But I can break my AF to become AC plus 6. Because anyway, they're asking me to find unknown AC. So you just put, this is AC plus 6 over my DF. DF is 8. So it's 8. So now it becomes an equation with the unknown AC. So I'm going to simplify this. This is 24 over 6 equals to AC plus 6 over 8. This one you can reduce first. Okay, divide by 6, divide by 6. So it's actually 4 over 1 is equals to AC plus 6 over 8. Cross multiply. So I have AC plus 6 is equals to 32. So my AC is 32 minus 6. So my AC is equals to 16 cm. Okay, we are done. Okay. So we are done with the part E. Okay, now part F. Part F, they ask, G is another point on the circle such that GB, B is here, GB and is equals to EA. So they are saying, okay, something like this. They are saying that, let's say maybe this one is my G. So they are saying that, okay, DG, yeah, I'm going to draw dotted so that I can confuse. They are saying that this and this is equal. Oh, it's 26, Sorry. I follow my answer. Yes, correct. Okay, you're right. Thanks for being attentive. My super powerful mental calculation. 32 minus 16 is 26. Thanks for highlighting. Okay. Okay, good. Part F. So they are saying that these two are the same length. They say, what can you say about the perpendicular distance of GB to the center? Okay, you need to know this property whereby, okay, I'm going to just draw out here, chord. This is called a chord. If they say that the chord is equal length, what can you say about the perpendicular distance from the center O? So they are talking about if these two are equal, okay, what can you say about the perpendicular distance to the O? They are equal. Understand? If this length is equal to this length, these two will be equal. That's the property. So you will say the perpendicular distance from the center for B, G, and AE are equal. That's it. 1 mark. You don't have to say so much. Okay, important is you know that they're equal chords. As long as it's not diameter, it's called a chord. C-H-O-R-D. Okay, so that is for this question number 2. Okay, so let's move on to question number 3. Hi. Okay, the diagram below is not drawn to scale. Okay, again, let's read the questions and make sure that all the information are transferred into the diagram. So in the diagram, BOH is the diameter. So we have our O, so highlighted that this is our center. So ABC is the tangent. These two are the tangent. And 22 degree is stated there. 62.77 is also stated there. Stating your reason clearly, find angle FDB. So FDB. So we are supposed to find this angle over here. So I'm going to use the silid chord as well. Why? Take a look at this one. 1, 2, 3, and 4. Although it doesn't look like a quadrilateral, but it is because it's 4-sided and we have all the 4 points touching the circumference of the circle. So the opposite angle add up to be 180. So over here I have the 77, 62 as well as the 22. So all these 4 angles actually add up to give you 180 degree. So the first one, part A, we will know that angle FDB will be 180 degree minus 22 minus 77 and minus 62. And this is opposite angles in silid chord. And we will get 19 degree. Okay, so update this small angle over here. This is 19 degree. Okay. Next, part B. They ask for angle GOB. GOB. This one. Okay. So let's see what we have. So this one is because they did not have the base. So if you want, you can draw out the base so that you can see better. So I'm going to join the line from G to B. But of course, I'm going to draw a dotted line. Okay, now let's take a look. See, GOB and GDB, both same base, the GB. One is touching the center of the circle. One is touching the circumference of the circle. So that means their angle is double. That means angle at the center is 2 times the angle at the circumference. So in this case, we will know that we will say, part B, angle GOB is equals to 2 times the angle of GDB. So it will be 2 multiplied by the 22 plus 19. And that will give us 82 degree. Okay, and the reason, because they say state your reason clearly, you will have to say angle at center equals to 2 angle at circumference. And this will be for part B. Okay, and update the diagram. So this is 82, so I'm going to put here this is 82 degree. Okay, they ask for HBD. HBD. Hello Mayo, no problem. Hope you learn. Okay. Wow, just nice. Okay, so they're asking for this one. Full version. What do you mean by full version? As in spell out. Do you notice that I don't spell out the opposite? I also never spell out the angles. My quadrilateral also never spell out. Correct? I personally feel that as long as you write the reason, like in this case, we know it's opposite, and we also know this is angles, and we also know this is quadrilateral, okay, it is still fine. It is still fine. Okay? Because why? Because you're already better than those who never even write reason. Agree or not? Of course, you don't give the wrong reason. Okay? But. So, let's say some students say, okay, sure, then what if let's say you feel very unsafe? Okay? Like I always tell my students, during O-level, you're supposed to showcase whatever you have, like, it's like you have to showcase whatever Kung Fu that have learned for the past 4 years, correct? So why is it that you want to hide your Kung Fu when you are having a competition? Agree or not? It's like, okay, O-level. So why is it that I always tell my students, why do you need to skip, let's say for example, a working, step 1 to step 5. Why do you need to skip step 2, step 3, and straight away step 1 skip to step 4? I say, why do you need to hide the 2 steps? 2 reasons. If you hide the working, maybe the teacher may think that, hey, you never showed the proper presentation, they minus you 1 mark. Secondly is, when you skip 2 steps and jump steps, and then the chance of careless mistake is very high. So why take the risk? So I always tell my students during O-level, you're trying to showcase whatever you have learned for the 4 years left. So there's no reason why you should hide your Kung Fu, you understand? So that's why I always tell my students. So now, where am I? Okay, I'm supposed to find this angle over here. So, okay. Now, this is the diameter. This is the diameter. So when it's a diameter, remember I tell you, when it's a diameter, you need to find angle in a semicircle. So I already can see this over here. I know this will be 90 degrees. Okay. Now let's see. Okay. So I'm going to find, I'm going to state this angle first. Part C. I'm going to say this angle BDH is equals to 90. I'm going to say this is angle in a semicircle. This is 90 degrees. And over here, this one actually we know. You always can turn the diagram. Let's take a look. I'm given here 62. See here, DFB and DHB, it has the same base DB. So this is 62 degrees. Okay, angles in the same segment. You see that? Angles in the same segment. Same base, touch the circumference, so they are equal angle. So turn the paper, and of course then after that we will say angle BHD is equals to angle BFD, which is equals to 62 degrees. Reason is angles in same segment. So now we can find our angle HBD, which is the one they asked me to find. This is a triangle. I already have 62, I already have 90. So this one simply take 180 minus 62 minus 90. Okay, so now we will know, okay, angle HBD will be 180 minus 90 minus 62, that gives us 28 degrees. And the reason, angles in a triangle. Okay, my student also asked me, Cher, your one you put angles in a triangle. Can I put the, I think some students or some teacher ask you all to use the sum of angles in a triangle. It's the same. Okay, it's the same meaning, because we all know that triangle, the sum is add up to 180. So actually for me, I put this good enough. So here is 28 degrees. So update the diagram. This is 28 degrees. Okay. Now we need to find BCD. So let's see where's my BCD. BCD is over here. So I need to find this angle over here. Okay, I will need to draw the line from O to D. Okay, why? Because there is a property which we call it tangent from external point. So what is the property about? Sure, can you write the degree sign at the end instead of writing throughout. Oh, I know what you mean. Actually, I feel that that's fine. That's fine. If you don't want to write, it's fine. But for me, like I said, I'm careful, right? I don't want to give any reason for the teacher to minus my mark. So I will write lah. Okay, but of course, important is the final answer. You got to give the unit. Okay, final answer must always give your unit. So for part D, I'm going to write it here. Okay, I want to highlight this property. Okay, this property, it is okay, pardon my circle. So the property is the circle, center. Okay, I'm going to draw these two. Then the tangent, you draw the tangent. Tangent. Okay, so this property, this is O. Okay, this 2 point is the tangent. This tangent, so this one, the property called tangents from external point. This, draw one additional line, or you can say this one, draw from here to here. This is 90 degree and this is 90 degree. These two triangles here, they are congruent. They are congruent. Okay, they are congruent. Congruent means they are exactly the same. So when they're congruent, what does that mean? It means that this length and this length is the same. And of course, we know that the radius is the same. And the inside is a common side. So that's why this two is a congruent triangle. Symmetrical. Yes, good. Yes, congruent triangle. So in this case, just now I draw my O to D already, right? If you notice, this is O, B, C, D is exactly the same as like this kind of shape. Agree or not? So, if I want to find here, this is my 90 degree. This is also my 90 degree. So, now my question is, can I find this angle over here? See here, this angle over here. I turn the paper a bit. So, this dotted line here, I want to find angle DOB. How do I find angle DOB? Now look at this. Do you see DOB and DFB? DOB and DFB. Same base. One touch the center and one touch the circumference. So they're actually 2 times. No, not isosceles. Oh, isosceles. Isosceles also can. Yeah, you are also right. So this, you also mentioned isosceles, which is also correct, because over here I have my 28 degree. This OB and OD, they are radius. So this is also isosceles triangle. That's also one way to find this angle. Okay, you can take 180 minus 28, you also can find this angle. Good. Okay, I also can use my angle at the center is 2 times the angles at the circumference. Also can. You will still get the same answer. Okay, so I'm going to use the 2 times one. So I will say angle BOD is equals to 2 times the angle BFD, which is 2 times 62 degree, which will give us 124. So now I know this one is 124. Okay, so now I'm supposed to find the outside, right? So we know that angle BCD, we simply take 360 degree because it's a quadrilateral. 360. Oh, before that I have to state that this one is 90. So we have to say OBC, angle OBC is equals to angle ODC, which is equals to 90 degree, and you have to state that the radius is perpendicular to the tangent. So now I already show 124, 90, 90. So the fourth angle, just take 360 and minus the 3 angle. So we know, okay, so angle BCD will be 360 minus 90 minus 124, and we will get 56 degree. And we are done. So over here, you will have to say, yeah, actually, no need. So this one, tangents from external, tell us that it is congruent. So I have find the three angles. One is using radius perpendicular to the tangent. One is using the angles at the center equals to the two angles at the circumference. Or, like just now the student said, you can use the isosceles triangle to find the angle. BOD also can. And then after that, just take 360 and minus. And of course, this statement over here is because I use angles in a quadrilateral. And we are done. Okay. So this is how you do this question number 3. Okay? All good. I hope someone just now said that the homework for properties of circle, you are able to do your homework after you learn these 3 questions today. So we are done with the 3 questions.